Hello and welcome. Today's lesson is titled Functions, Yes or No. The objective of today's lesson is to identify whether a relation is a function or not. So what does it mean by the word identify? Identify means to look at something and establish what something or someone is. So for example, here I have some geometric figures. Let's say I ask you to identify the following geometric figures. What am I asking you to do? I'm asking you to look at them and tell me what their names are or what is their identification. So stop the video right now and take a few seconds to write the names of each one of these figures right here on the boxes provided. And when you have done that, restart the video to see if you got them right. So welcome back. You should have a look at these pictures and identify their names. The first one here is a circle. So let's write it down, circle. The next one is a rectangle. And the last one is a triangle. So what we have done is we have identified the three geometric figures on this paper. Now let's talk about relation. What is a relation? Relation is how two or more things are connected or related. So let's take an example. Let's go back to this geometric figures. Why are the rectangle and the triangle related? Please use a sentence stem when you answer. So you're going to say the rectangle and the triangle are related because they both have. Now you think about it and write it down on the space. So go ahead and stop the video, think about the answer for this problem, and then when you're ready, restart the video. So welcome back. So you had a chance to look at the pictures and decide the reason why the rectangle and the triangle are related. So what are some of the reasons? The rectangle and the triangle are related because they both have, well, we could say they both have angles. If you notice right there, this corner right here is called an angle. Here's a second, third, fourth. Here's the triangle. I have one, two, three angles. On the circle, I don't have any angles. Okay, and then what is another reason? The rectangle and triangle are related because they both have sides. Okay, so they both have sides. The rectangle has four sides and the triangle has three sides. Another thing that they have, so the reason why they're related is if you notice the circle has a pattern, but the rectangle and the triangle don't have patterns. So the rectangle and the triangle are related because they both have no pattern. So that could be some of the reasons you wrote of how these two geometric figures are related. So now that we talked about identify and relation, let's look a little bit deeper into mathematics and what is a relation in mathematics? Well, a relation in mathematics is how two or more numbers are connected or related. So let's see how we show or represent those relations in mathematics. The way we do it in mathematics is we use graphs. We can use something called tables. We can also use set of order pairs and mapping. So we're going to look at of each one of these four types of representations. So let's start with the graph. This is called a coordinate plane. If you notice, I have two axes, the y-axis, which is the vertical one, and the x-axis, which is the horizontal one. And basically, these points represent the relationships between numbers on the x-axis and with numbers on the y-axis. So right here, this point right here. So basically, I start at the x and I kind of like move up until I see the point, so which is right here. And when I get to that point, I go across and I see that number one is related to number four. I can do the same thing with number two. I go up and then I go across. And when I go across, I see that that point right there touches number one. So two is related to one. The next one is three. and 3, if I go across, tells me that it relates to number 2. So down here, I wrote it down in words. 1 relates to 4. 2 relates to 1. And 3 relates to 2. Now in mathematics, we usually don't write the word relates to. We have a shorter way to write, which is we write the numbers in parentheses. The x number is the first number followed by the second number, and they're separated by a comma. So 1 relates to 4 is written parenthesis 1, comma 4, close parenthesis. The second relationship is parenthesis 2, comma 1, close parenthesis. The next one is parenthesis 3, comma 2. So right there, those 3 points, those 3 relationships are represented with what we call order pairs. So order pairs. Now the reason why these things are called order pair is because they are in order. The order is the first number represents X, second number represents Y. Just like in the alphabet, X comes before Y. So this is in order and is a pair because it's a pair of numbers. Now that leads us into the next type of representation for relations, which is a set of order pairs. So basically the word set means a group. So a group or a list of order pairs. Okay, so group or list. So here we have a list of order pairs. 1 pair, 2 pairs, 3 pairs. Now let's see how we write a set of order pairs. We use this symbol right here, which is the curly bracket, called curly bracket. So let me write it down here. Now inside those curly brackets, we have the parentheses. So let's write it here, the name parentheses. And please notice that those parentheses and the numbers inside the parentheses are separated by this symbol right here, which is a comma. So that is a comma. So in order to write a set of order pairs properly, or in other words, the right way, you're gonna open curly bracket and represents the order pairs inside parentheses. And you're gonna separate each parenthesis or set of parentheses with commas. And then you end by closing the curly bracket. So this is showing the same thing as the graph. And that leads us to the next type of representation, which is tables. You could have 2 types of tables. The horizontal table that looks like looking in the horizon when you go into the beach and you look out into the ocean, you see the sun out there on the sky and you see the ocean right there. So this is what is called the horizon, horizontal. And then vertical is up and down. So notice that on a table, the X value, when it's on the horizontal, is on the very top. And the Y value is on the very bottom. Now, if it's written vertically, then the X values is the first column, and the Y values is the second column. And look how they are showing the same representation as the graph. 1 relates to 4, 2 relates to 1, and 3 relates to 2. Same thing happens on the vertical table. 1 relates to 4, 2 to 1, and 3 to 2. Just like we wrote it right there. So right now we learned 3 representations. The graphs, the tables, the set of order pairs, and the last one is called the mapping. And the mapping has 2 circles like this, or 2 ellipses. Okay, this is called an ellipse. Okay, and on the left side is the X values, and on the right side is the Y values. So here I wrote numbers 1, 2, 3, 1, 2, 4, and if you notice, 1 relates to 4, so I connect 1 with 4, 2 with 1, and 3 with 2. So this is a way to show the relationship, and the relationship is shown through arrows. Okay, So there we go. These are the four types of representations in mathematics that we use in order to show relations. All right, now that we talk about relations, let's talk about a very specific or special relation called function. Okay, so on the next page, we're going to learn about function. Function is a relation where each value of x is related with a single y value. Okay, so let's see what that means on each one of the representations that we learned on the previous page. So remember, we have four representations: graphs, set of ordered pairs and tables, and mapping. So how do I know if, when I look at a graph, if I have a function, yes or no? Okay, basically we're going to use what is called the vertical line test. So the vertical line test, to be a function, the vertical line must touch only one point at a time as you move the line from left to right. So imagine a line. So we're going to use the pencil right here as our vertical line. And imagine that I'm going to move this pencil across from left to right on the coordinate plane. So as I move across, my pencil is going to touch the graph at one point right there. Then if I move again, it's going to touch one point and one point. So I'm only touching one point at a time. So because I'm only touching one point, then it is a function. Now imagine that if I have my pencil here and I'm moving across, and what's happening? I'm touching 2 points at the same time. And that is a big no-no. That is not a function. To be a function, you can only touch one point at a time. Now let's talk about order pairs and tables. Okay, remember, set of order pairs looks like this and tables looks like that. And the rule is, to be a function, the x value cannot repeat. So where's the x value? Is the first number inside the parentheses. And if you notice, -1, 0, and 1 do not repeat. So that means this is a function. On a table is a little bit easier because all the x values is lined up, and I can definitely tell that the x does not repeat. Now let's take a look at this one right here. Here I see the -2 repeats, and they are positioned on the x value, so then this is not a function. Look how easy it is on the table right there. The -2 and -2 is kind of very easy to see and identify, so we know that this is not a function. The last one is the mapping. In order to be a function on a mapping, it has to have two conditions, and that's where this and is like so important. Okay, the first condition is the x value cannot repeat. So let's look at this. Does the x value repeat? I don't see it repeating, so it met the first condition. The second condition is there should be only one arrow coming from the left to the right, or one arrow coming out from each number on the left. Okay, there's one arrow, one arrow, one arrow. It passes the two conditions, so it is a function. Compared to this one right here. Here, the first condition is not met because look at that, 3 and 3 repeats. So because of that, it's not a function. But not only that, look at this. How many arrows coming out of 8? How many arrows coming out from the left to the right? 2 arrows. That's another reason why this is not a function. So what we're going to do right now, we're going to do a guided practice. So basically, you're going to stop the video. You're going to decide or determine. So that means determine means to decide whether each relation is a function. So here we have 9 problems with different representations. And your job is to determine, is it a function, yes or no? So stop the video, answer the 9 questions, and then restart the video to check your answers. Welcome back. So basically you try these 9 problems. So let's see what you got. If you look at this graph, you're going to do the vertical line test, and I'm touching 1 point, 1 point, but right here, I'm touching 2 points. That's a big no-no, not a function. Here we have a table, and a lot of people look at this and it's like, oh my goodness, the 3 is repeating. So that means not a function, but wait a second. This is the y values. We don't care about the y values. We care about the x value. Okay, that's what we'll need to look at. Does the x repeat here? No, all the values are different. So that means it is a function. But they repeat over here. It doesn't matter. This is the y values. All we care about is the x values. The x values don't repeat, so yes, it is a function. How about here? We have mapping. I see multiple arrows coming out from the three. Like I see one, two, three arrows, and here I see two. So right there, not a function. Let's go on to the next one. Here I have a set of order pairs. So I focus on the x value, and look at that. The number 4 repeats. So because the x repeats, it's not a function. And look at this table. I also have 4s that are repeating. And these 4s are repeating. Again, not a function. Let's try this one. Look at the x values. They don't repeat. So yes, it is a function. Be careful. I see that the 3 repeats, but does it matter? They are the y values. We don't care about the y values. We care about the x, okay? So it doesn't matter if the y repeats. What matters is, does the x repeat? And in this case, the x does not repeat. So it is a function. All right, the next problem. Here I have a mapping. And at first sight, I see only one arrow coming from the left. And I'm like, woohoo, it is a function. But be careful, because there is a trap right here. You see the number 2 right here? And this number 2 right here? They're equal. And that means the x is repeating. So that means this is not a function. Remember, on a mapping, 2 conditions must be met. One arrow coming from each number on the left, and only one arrow, okay? And the second condition is the x cannot repeat. And that's the problem here. The x is repeating. All right, let's do number 8. Number 8 is a graph, so I'm going to do the vertical line test. So I'm moving my pencil across, and I'm only touching 1 point, and guess what? It is a function. Very different than this one, because when I move my pencil across, I'm touching 2 points at the same time. Not a function. Okay, so that concludes our guided practice. So that means now you're ready for your independent practice, and that's where we're going to do the assignment. Okay, the assignment is a piece of paper that has problems in the front and on the back. So your job right now is to try, just like we did in the guided practice, to determine, to decide whether the relation represented on this representation, is it a function, yes or no? So take your time to do this. And if you don't finish everything in class, you can finish at home. But if you finish in class, you turn it in. Now, before I finish the video, let me just summarize or conclude by saying that today, our objective was to identify whether a relation is a function. In other words, today we learn to identify whether a relation is a function. What are some of the keywords we learned? Identify, to establish what something or someone is. We learned about relation, how 2 or more numbers are connected or relate to each other. And we learned about a special relation called function, where each value of x is related to a single value of y. We learned how to identify whether it's a function or not, or how to determine, looking at 4 different rules, for one for the graphs. Okay, so if I have a graph, the rule is use the vertical line test, and if you only touch 1 point at a time, that means it is a function. But if you touch 2 or more, not a function. If you have a list of order pairs or a table, the x value cannot repeat. And it's easy on the table. On the set of order pairs, just look at the first number of each parenthesis, and we see right there the x doesn't repeat, so this is a function. Now, if the x repeats like here, then you know it's not a function. And the last one is the mapping, which has 2 conditions. The x cannot repeat, and I must have only one arrow from left to right. So this one passes the test. This one has 2 problems. It does not make the first condition, the x repeats. And also, there's 2 arrows coming out of here, so this is not a function. So this is what we learned today. I hope this video was helpful. Thank you very much for your time and have a wonderful day. Bye bye.